Welcome to JD's Prep. So for the next few questions, we are going to be talking about mica. I'm going to start with going through this blurb. So the familiar term mica is not the name of a specific mineral, but rather the name of a family of more than 30 minerals that share the same properties. All members of the mica family have high melting points and are similar in density, luster, hardness, streak, type of breakage, and crystal shape. As a result, telling the micas apart can be difficult. However, some common members of the family can be identified by color. For example, biotite is black to dark brown, while muscovite can be light shades of several colors or even colorless. When less common members of the mica family have any of these colors or have similar colors, chemical tests are needed to tell them apart. All right, so that's a little bit of background that we're given. First, we're asked to identify the two chemical elements present in biotite mica that are not present in muscovite mica. So for this, we are going to want to head to your reference tables, to the properties of common minerals. The page on that, I've just taken a clip of that. The piece that gives us muscovite mica and biotite mica, so we can compare the two. So we're being asked to identify the two elements present here that aren't present in the other one. So all you need to do is examine the chemical formula, determining the composition, right? And we have magnesium and iron are both chemical elements that are present in biotite mica that are not present in muscovite mica. So our correct answer is magnesium and iron. Next, we're asked to identify the luster, hardness, and dominant form of breakage for members of the mica family. Now remember, we've been told that all members of the mica family have high melting points and are similar in density, luster, hardness, streak, type of breakage, and crystal shape. So from that, we can assume that if we look at the information about the muscovite mica here and the biotite mica, that we can determine the luster, hardness, and dominant form of breakage for all members of the mica family. All right. So we're going to just use these properties of common minerals to determine this. Both of the highlighted micas in there, they have a non-metallic luster. Their hardness, we're going to say between 2 and 3. And the dominant form of breakage is cleavage. Next, we're asked to state the name of the igneous rock in which crystals of biotite mica are larger than 10 millimeters in diameter. You're going to head to your scheme for igneous rock identification. Here, under crystal size, we're looking for this bottom section, 10 millimeters or larger. You can see that the rock identified there is pegmatite, and indeed, we see right here that there is biotite present there. So our correct answer is pegmatite. And for our last question, large crystals of mica, sometimes weighing several hundred tons, so very large crystals of mica, have been found in igneous rock in Canada. Identify the environment of formation and the relative rate of cooling of the magma that formed the igneous rock containing these large crystals. So our key here is large crystals. If we have large crystals like that, that means that the environment of formation would be that magma is cooling underground. We'd call that intrusive. And the relative rate of cooling is very slowly. All right, thank you for using JD's Prep.